let me show you my solution to calibrating the belt tension for Geeetech A10, A20M, and Ender-style FDM printers. Like many of you, I've spent many meters of PLA calibrating E-steps, temperature settings, slicer settings, and bed leveling in the pursuit of printing out the perfect little benchy. Off I'd run to the wife, holding out my hand, proudly displaying my latest addition to my growing fleet of benches. My joy would be short-lived though, as she looked over the little craft with a degree of scrutiny that I would usually expect from the likes of Sherlock Holmes. Then came the dreaded sentence. "Is it supposed to have that pattern on the hull?" My wife had quite literally torpedoed, verbally, my latest benchy. It has now joined my growing armada of shipwrecks. So, to calibrate the last thing on my list, that is, the stepper motor drive belt tension, I created the HX-ATMega. The 34mm square PCB has an ATMega 328P and a HX-711 strain gauge amplifier in a format that is dedicated for the belt tension application. The Arduino program allows for simple calibration, as well as providing a flexible choice of application. I also added the feature, or should I say, application of measuring the remaining filament on the reel. With the switches on the PCB, you can go through the menu and quickly set the relevant parameters. For belt tension, you can choose grams or newtons. The choice is yours. You need only perform the calibration once. Set 0 and calibrate for a given weight of 1 kg, 5 kg, or 10 kg. I won't be offering any specific advice on the tension you should set your belts to. However, there are a number of great YouTube videos that detail the exact tension the belts should be set to. Or at least a very close approximation. Knowing the stepper motor radial limits is preferable. This, plus much more, will be detailed in the manufacturer's data sheet. As you can see, on the x-axis I've mounted a prototype HX-ATMega, measuring tension in grams instead of newtons. It's showing about 1000 grams, which is about 10 newtons. I normally set the tension to about 2000 grams, that's about 20 newtons. Interestingly, the tension on the x-axis can be seen to change depending on the position of the carriage on the gantry. This is quite normal. So I normally calibrate with the carriage centered. I had a few of these boards to spare, so I created a couple of alternative reel modifications to measure the remaining weight of filament. The Arduino program then calculates the length or volume of remaining filament, depending on the filament density. These reel mounts I further modified with a humidity sensor and larger OLED display. Just for fun. I also used a 1 kg bar load sensor instead of the 34mm square 10 kg one, as this reel holder would be measuring a maximum of 900 grams or so. This last example is my personal favorite. This time, the 34mm 10 kg full bridge strain gauge sensor is mounted above the PCB. On the sensor is mounted a small platform where the filament reel can freely rotate on a set of 4 bearings. The bearings have an outer lip that prevents the filament reel from sliding to the side. This one I have set for length, so I can see how many meters of filament is remaining. I calibrated the HX-ATMega using a 10 kg weight. The HX-ATMega uses a ATMega 328P. Its CPU is clocked at 16 MHz. On the board is a HX-711, along with 2 LEDs. One for power, and another for user control. The complete board is LED-free in accordance with EU regulations. A 0.91-inch OLED display can be directly connected to the I2C port, and pin allocation matches the I/O directly. There are 3 switches. One reset switch, to reset the program. The other 2 switches are under program control. That is, these trigger an interrupt-based routine that facilitates menu navigation and selection. In addition, there are a number of other I/Os not in use, but are available for the user to play with. The PCB will accept a 5.5 volt to 16 volt DC supply, or a 5 volt DC supply directly. Please ensure that the supply used is a stable one, and is reliable. Jumper JP1 can be cut to allow usage of the 5 volt DC supply connection. The board and connected OLED display will use about 30 mA. Thank you for watching this video. I hope you enjoyed it and found it useful. If you did, then please click on the like button. Depending on the response, I'll be adding additional videos in future. I mentioned I made a few of these boards, so if you are interested in purchasing the HX-ATMega, please head over to www.beltech.de. I'm selling the 10 kg full bridge strain gauge as well. This particular strain gauge is difficult to source outside of China, so availability will strictly be on a first-come, first-served basis. I'm still in the process of setting up the site, but the shopping cart system is up and running. Anyway, thanks again. I'm off to print another benchy. I have a feeling this time that my next little ship will pass muster.